The original orange juice problem was we drink 1 ounce and replace it with water and keep repeating, and we want to know how many calories we're getting with each drink, right? Okay? So what? Let's see. Well, drink 1 ounce, there are 9 ounces left, right?
Mm-hmm.
Now there are 14 calories per ounce, right? So that's obvious, I'm not going to belabor that. So we drink 1 ounce, there are 126 calories left, and we're going to replace that, right? And now we have 126 calories. Ten ounces, that's 12.6 calories per ounce. We drink 1 ounce, and that leaves what?
Let's see. That leaves 113.
I think that's 113.4 calories, right?
Mm-hmm.
Okay? And of course, we replace, just to remind ourselves. And now they're 11.3 calories per ounce, right? And we've got a calculation scheme that we can easily follow. Okay? So that's pretty easy, right? That's not always the way people solved it, and it's not necessarily the best way to solve it, but it's maybe the most direct that gets all the details, and you may be the most confident of, right? But it's totally equivalent to doing this. Okay? One ounce is 10% of your solution, right? So at every step, so every drink consumes 10% of calories in solution, right? Leaving 90% of the calories, right? Okay? After one drink, you have 90% of 140 calories, 126 calories, same answer, right? After another, we have 90% of that, and I'm writing that as 0.9 times 140 calories. I don't want to write down that 126. Not that it's easier to write this, but this tells us more about the progression of these numbers, right? After another, we have 90% of that. Well, I'm getting tired of writing down all those .9s. What am I going to do about that? Well, I'll note that this is 0.9 squared times 140 calories, so I can calculate that directly, right? Make sense? And this is 0.9 cubed times 140 calories. And then I'll put a couple of dots so that I can say after n drinks, we have 0.9 to the n, or it doesn't want to let me write an n there. 0.9 to the n times 140 calories, right? So how many have we consumed? Well, this is how much we got left, this is how much we started with, we've consumed the difference. Okay? And of course we can do a little factoring and write that as 140 calories times 1 minus 0.9 raised to the n, right? Okay? Make sense? You know anything about geometric sequences? You ever seen that?
Yeah.
Closely related. I mean, yeah. The numbers you get here are a geometric sequence, right? Okay.